I actually just redid it. It is 6.
Okay, so we agree that that's a 6 there? Okay. All right, so we copy down our coefficients here, right? So 2, -10, +14, -24. The 2 gets brought down. 2 times 4 is 8, so that is -2. I don't know. If you guys said -2, I apologize. I might have wrote that wrong. So it should be 2x squared minus 2x. 4 times -2 is -8. And there we get the 6. Okay, so it is a 6. 4 times 6 is +24, so we don't have a remainder. So that works out nicely. Right, so I'll write it a little neater down here. 2x squared minus 2x plus 6. What's up?
I thought that 4 became -4. Becomes -4.
This 4?
Yeah.
Okay, so remember, when we have x minus k, we're just looking for what k is. So we kind of ignore the negative sign. If it's a negative, then we just take whatever the number is. If it's positive, then that would be a negative out there.
So you're always doing the opposite?
Yes.
Okay.
Okay. Right, yeah, so it'll always be the opposite sign from here to here. Okay. Any questions about general synthetic division? All right, so today we're going to learn two, well, really one, but it kind of expands to two theorems that we specifically use synthetic division for. Okay, and it's a little quicker using synthetic division than doing the long division method. So the first theorem is called the remainder theorem. Okay, so we're starting off, right, with normal division. So we have a polynomial f of x. We're dividing that by x minus k. Then what we can say is that whatever that remainder is would be the solution if you plugged k into the function. That's okay. Let me make that look a little nicer. Okay, so we can use synthetic division to evaluate our functions instead of our normal method of substituting and solving. All right, so we would use this if we have a very large, maybe high degree polynomial where it would be a little more work to plug in the number and try to figure everything out, or we can just set up a quick synthetic division and find the solution. So going back to this, okay, if my f of x was the function at the beginning, okay, so 2x to the third minus 10x squared plus 14x minus 24, right? If I want to find f of 4, if I plug in 4, okay, I can just do this, right? If I just plugged in 4 here and, maybe I didn't have a calculator on me, that'd be a lot of work. I'd have to do 4 to the third times 2, right? 4 squared times 10, 4 times 14 minus 24, okay? That can be a lot. Or you can just do your zigzag pattern for synthetic division, and you know that f of 4, in this case, is equal to 0. Okay, if you plugged in 4 in there, you would get 0. All right, so let's take a look at another example. Okay, so we're going to use the remainder theorem to evaluate 3x cubed plus 8x squared plus 5x minus 7 at x equals -2. Now be careful. Here I'm giving your k in a different method, in a different way than we saw before up here. Okay. Here, essentially what we do is we set that equal to 0, and we get x equals to 4, right? So that's why we take the opposite sign when they give you the equation. If they tell you x equals something, that's going to go over on the outside. All right. So again, here, this is just giving you x equals k. So when it's x equals, you're just taking whatever you see here, and that's what you're moving outside. If they told you x plus 2, then you would take the opposite sign to put it on the outside. All right, so be careful there moving forward. Again, if they tell you equal, you're just putting whatever number they tell you it's equal to. All right, so everything else is the same. Bring down our coefficients. All right, and we're going to do synthetic division. So for this instance, this part here, the numbers outside of the remainder don't really matter. Obviously, you need to find them to find your remainder. But we're not really concerned about what's going on here. Okay, I don't care about what function I may get, what polynomial I may get as a result. All I'm focused on is that remainder here. So -2 times 3 is -6. We bring that down, that's 2. -2 times 2 is -4. We bring that down, we add and get 1. -2 times 1 is -2. -7 plus -2 is -9. So boom. Without really doing any math, I can tell you that f of -2 is -9.
Wait, -2 times -4.
Okay, be careful. No. So we bring down the 3. 3 times -2 is -6. We add down 8 plus -6 is 2. 2 times -2. Okay.
Yeah, I got it. Thank you.
No problem. Yep. And obviously, you can always check, right? You can plug in -2. So we would have 3 times -2 to the third plus 8 times -2 squared plus 5 times -2 minus 7. But right, like I said before, maybe I don't have access to a calculator right now. Maybe, my phone wasn't giving me the right answer. You have to be careful because a negative to the third stays negative, but a negative squared becomes positive. So you might mess up somewhere with the signs, okay? But here we get -24. Here we get a positive 32. Here we get -10 minus 7, right? And we add and subtract all those together, and we do get, in fact, our -9. All right, so again, we can use that. I think doing this was much quicker than, getting out a calculator and typing all that in. Okay, any questions there? Okay, that brings us to our second theorem. All right, using this factor theorem, the remainder theorem, we have okay. First, write this down. Second, I have a question. Have you seen this before? Have I done this in class before? IFF?
I haven't seen it before.
Okay. So we're going to do a little side. So write this down. Okay, so we can say that a polynomial f of x has a factor x minus k if f of k equals 0. Okay, so that's just the rule of a factor, right? We know that a factor, when you plug in the value of that factor, equals 0. Okay, that's what it is. A solution is a factor, is a 0, is an x-intercept. They're all the same thing. Okay, little side lecture. When you see IFF, it stands for if and only if. So this is a logic symbol or abbreviation. So in logic, a logical statement would be something like, they're called if-then statements. Okay, so you would say something like, if it is raining, then I will bring my umbrella. Okay, well, today it's raining, so I'm going to bring my umbrella. I will have an umbrella with me. Okay, so that's an if-then statement. Okay, with that, it only goes one way, right? If it's raining, then I have an umbrella. If I have an umbrella, it may or may not be raining. I can't go like backwards with that. Okay, when I say if and only if, that means my statement goes back and forth. Okay, so it is raining if and only if I bring my umbrella. That means the only time I'll have my umbrella is if it's raining. Okay. I really wish I could go into this logic stuff a little further. Okay, like I said, maybe at the end of the year, if we have time, we can do that. Because I think it's really good for, debates. It's good for just critical thinking in general. But they took it out of the curriculum. So, okay, so this means both things must happen. So a polynomial f of x has a factor if you plug it in and it's 0, and the backwards is also true. If you plug it in and you get 0, then it is a factor. Okay. All right, so let's see an example. Yeah, we got some time. Okay, so we're going to, we're going to show that x minus 2 we're going to show that x minus 2 is a factor of our polynomial here, 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. All right, so we set up our synthetic division like we normally would. All right, so we take the opposite because it's x minus. So we're going to have a positive 2 on the outside. Okay, I'm not missing any terms here, so I can just write down my coefficients. All right, and we do our synthetic division. So again, these numbers out front don't necessarily matter right now. Okay, I'm just looking for this number here. In this particular case, I want to make sure that that's equal to 0. 2 times 2 is 4. 4 plus 7 is 11. 2 times 11 is 22. 22 plus negative 4 is 18. 2 times 18 is 36. Yes. 36 plus negative 27 is 9. 2 times 9 is 18. And we get a 0. Okay, so you would say, yes, x minus 2 factor of our function. Okay, and if you got a number other than 0, then it wouldn't be a factor, and you would say no. Okay, any questions on that? Okay, so what we're going to do tomorrow now is you're going to take this we're going to take this a step further, right? So because this is a factor, then I can go back and I can say that my function, right, if this was f of x, so f of x is going to be equal to my factor x minus 2 times whatever I have left over here, 2x cubed plus 11x squared plus 18x plus 9. Then you can go even further and factor this, and then you can keep factoring. All right, so that's what we're going to move on to doing. All right, so tonight you're going to have a few questions, pretty much using the remainder theorem that we did on the page before, and maybe one on the factor theorem, and then we'll apply that to some higher order things tomorrow. All right, guys. So if you don't have any other questions, that's all I got for you guys today.